Hey guys, welcome. So today we're going to be talking about solving rational equations. So we've been doing all sorts of fun things, simplifying, multiplying, dividing, adding and subtracting, and now we're going to be solving. So today is just going to be kind of an intro, some of the easier-ish problems. So just try to follow along and you'll have a few practice and we'll kind of go from there. So here's kind of our most basic one. So this is a rational equation, because as we look at it, we got some fractions going on. Oh my God, what is going on with me? This should be an X, guys. I'm sorry, I'm a mess. I refuse to start over though. So there we go. Sorry, trying to copy. I'm copying the wrong thing. So we start with this equation. It's rational because it has some fractions. And I'm just going to go back and remind you of the good old days, Algebra 1. And if we ever had an equation with a whole bunch of fractions, we could kind of remedy that by multiplying the entire thing by the common denominator. And that's basically the main thing that we're going to take out of today. Multiply everything by the common denominator, and then you'll be able to solve. In this case, remember 7 is over 1. The common denominator would be 10. So as I multiply through, I'm just multiplying each of these by 10 and reducing as I go. So I would have 10 times x over 5. That would just reduce to be 2x, right? Plus 10 times x over 2. That would reduce to be 5x. And then just 10 times 7. And that would give me 70. So not a bad setup. We can see that multiplying it by the common denominator made it way easier rather than having to combine and do all sorts of funky stuff. So we can solve this quick. 7x equals 70, x equals 10. We're good. Now, one thing we do want to get used to in this section, it's not going to affect us too much in this problem. It's more when we have variables in the denominator. We do always want to check our answer. So I usually do that right in my calculator. For my check, I just grab my calculator and I throw in 10 over 5 plus 10 over 2, and I want to make sure that it equals 7. So sometimes it will come out that the sides are not equal, so that would actually not be a solution. We call it an extraneous solution. And sometimes it will turn out that in your denominator you might have a 0, which we know goes against everything we believe in. But that really just gives me 2 plus 5, so I would just do a quick little check that I did check that. But it's just a habit you want to get into doing whenever you are solving a rational expression. Once again, it doesn't really affect this one, but it's a habit. We'll just start. So that's kind of the most basic. Nothing too crazy going on with the denominators, but getting rid of that using that common denominator. So then we'll have another one kind of similar, except this one will have a few polynomials in it. Okay, so I'm going to multiply everything by the least common denominator. In this case, the least common denominator would be 6. So I kind of choose that first. From here, I'm just going to kind of write for each of these are getting multiplied by 6 times 6 times 6. And then it should reduce, so now we don't have any fractions left. So we notice here those 6's are going to cancel out. I'll be left with 2x plus 1. We notice here that that would reduce to 3, so that would give me, why do I keep writing the wrong thing, plus 3x. And then over here, this would reduce to 2, so we would have 2 times, make sure you're multiplying the binomial, so 2 times x plus 1. So on this right side, I can combine here. That would give me, 5x plus 1. On the right side, I can distribute. Now I'll get my x's together, get my constants together, and solve. And that gives me my final answer. All right, that wasn't too terrible. Let's just get into the habit of starting to check. Once again, if it doesn't work when you check, it's called an extraneous solution. So I just do, quick, 2 times -1 plus 1 over 6 plus -1 over 2 equals -1 minus 1 over 3. So I basically just end up throwing this in my calculator or just doing it quick in my head. And then checking the side. And if you did check it, it does come out. So I did it a few minutes ago, hint. But just as a heads up there. Okay, so nothing too crazy going on as of yet. Maybe even problems that you've seen one similar to. So let's try one where we see some variables in the denominator. I think I can make it on the bottom of this paper here. So let's go. So we have 5 over 2x minus 2/3 equals 1 over x plus 5 over 6. Okay, so looking similar, we do have a bunch of fractions. Main goal is we don't want them, so they're kind of a pain to solve with. So we're going to multiply everything by the common denominator. So just look, you have a 2x, a 3, an x, and a 6. So I kind of think about my integers first. The GCF of those would be 6, and then these have x's, so I have to have an x. So everything in this case is going to get multiplied by 6x. So I just kind of go through and put it next to each term, so I can kind of reduce as I go. So what I see here is the 6 over 2, why can't I talk today, reduces to 3, and the x's cancel. So 3 times 5 would give me 15. Here, the 6 over 3 reduces to 2, and we have the x, and then times 2, so that would give me 4x. Here, the x's would cancel. 6 times 1 is 6. And here, the 6's would cancel. X times 5 is 5x. Okay, so I always like that part. It feels very satisfying to see things cancel out. But now that I have this isn't too bad of a solve. I'm going to get my x's together. I'm going to get my constants together, and I'm going to solve. Okay, we got an answer. We are going to check it. So you plug it back in. Once again, I'm showing my work if you're kind of checking in the calculator or off to the side or whatever, but please make sure you're going to see in a second. We're going to do a magical one where there is an extraneous solution. You do always want to get into the habit. Ooh, why do I keep writing the wrong things? Plus 5, 6. So if you throw that in, 5 over 2 minus 2/3. If I added it with there, once again, I just check these. So I do know that that works, but I kind of just plug in the left side of my calculator, the right side of my calculator, and make sure I'm good from there. So once again, we kind of just, instead of just having numbers, we throw in some variables there. Same idea though. We found what they all had in common. We multiplied everything. That helped us reduce, and then it made a way easier equation to solve. Fabulous. So just a few more. Nothing too crazy. So let's try this one. We got 1 over x plus x over 2 equals x plus 4 over 2x. Okay, so that doesn't look too bad. I remind myself we have an equation. I don't want to deal with this. It's a big hot mess with all the fractions. So I want to get rid of the fractions. I'm going to multiply by the common denominator. X, 2, and 2x. The common denominator is going to be 2x. So I'm going to multiply everything by that. So in this case, the x's would cancel. I would just be left with 2 times 1, which is 2, plus. Here, the 2's cancel. X times x is x squared. Here, the 2x's cancel, and I'd be left with x plus 4. What a beauty. We have a quadratic, good old quadratics. You have an x squared, so we are going to solve it. This is going to be factorable, hint, hint, because we've been factoring forever. But when you solve a quadratic, you do want to set it equal to 0 when you're using factoring. So I have the x squared. I'm going to subtract the x. So I'm just going to leave that as x squared minus x, and I'm going to move the 4 over here. That'll give me minus 2 equals 0. We'll do a good old-fashioned factoring. That would give me what? X minus 2x plus 1. And then just as a reminder of how you solve, you just plug both them in and set them both equal to 0. And you would get your two answers of 2 and negative 1. Boop. Boopity boop boop. And then you would just plug those back in. So always do your check. You do have to check 2 answers. So if you get 2 answers, you got to check 2 answers. So 1 over 2 plus 2 over 2 is going to equal 2 plus 4 over 2 times 2. But that makes sense because that would give me 1.5. And then over here, that would give me 6 over 4, which is 1.5. So we're good. And then you check the second one as well. 1 over negative 1 plus negative 1 over 2 is going to equal negative 1 plus 4 over 2 times negative 1. So once again, just do your math out. That would give me what? Negative 1 minus a half is negative 1.5. And then that would give me 3 over negative 2, which is negative 1.5. We're good. But do check that. Sometimes it will come out that one answer will work and one answer won't. It's so exciting. Okay, so we're checking along. We only have 2 more problems. Feeling good, hopefully. So let's see what we got. Let's do, sorry, all my problems everywhere. Okay, So this is a rational equation because we have fractions, but this is a special equation. We've seen it before this year, and you've seen it in the past. This is an equation called a proportion. So just as a reminder, you can technically do what we do with the other problems, where you could multiply by the common denominator, but in this case, you can also just cross multiply. So if you ever just have fraction equals fraction and you don't have any other terms, feel free to use that cross multiplying step to help you solve. I always find if I see a proportion, I just usually cross multiply. Saves me from having to do that little extra work. Because now we have the equation, we just have a little bit of simplifying, a little bit of solving. So 21 is going to equal 9x, and then we'll just reduce that. So 21 over 9 gives me a final answer of 7/3. I'm going to check my answer. So 3 over 7/3 is going to equal 12 over 7/3 plus 7. I don't know. So I'm getting lazy here. I grab my calculator. Well, 3 over 7/3 I can do, but that's going to be 9/7. So once again, I'm just using my calculator just to quickly check. I'm going to do that denominator first. So I have 7/3 plus 7, and then 12 divided by that gives me 9/7. So I've now reminded myself that that is in fact an answer, and I'll go from there. So this is going to be our last problem. I'm going to give you a hint. It's going to be magical. And the hint is going to be, this is going to have an extraneous solution. So you're going to notice, I'm not going to know that as I'm actually doing it. So what does it actually look like? So I have this equation. I look and I say, oh, that looks kind of messy. So let's get rid of those denominators. I'm going to multiply everything by x minus 3. That would be my common denominator, right? Remember, that's over 1. So times x minus 3 times x minus 3 times x minus 3. I kind of just put it with everything. In this case, nothing cancels in this first one. So we have x times x minus 3. Okay. Here, that cancels. I have plus 6. And here, that cancels, and I have 2x. Okay, so that wasn't terrible. Let's do a little just bit of simplifying. X squared minus 3x plus 6 equals 2x. I'm sorry, there should be an x there. Okay. Let's set it equal to 0. When you see these quadratics, you are going to set them equal to 0 so you can solve them. We're going to do more with quadratics next chapter, but as of right now, we should be able to solve by factoring. So that would factor to x minus 2x minus 3. And then I can set both of these equal to 0 to get my two answers. And my two answers come out to be x equals 2 and x equals 3. So I'm feeling pretty good about life. Okay, I solved it. I'm doing good. You need to check it. Check our row. Okay, so let's throw in the 2. So 2, or I can just write 2. I don't need to write 2 over 1 in that. Plus 6 over 2 minus 3 equals 2 times 2 over 2 minus 3. So yeah, I kind of just like throw this in, okay? Oops, sorry. Paper's getting a little rowdy here. So off to this side. Well, that's 6 just divided by -1, right? Plus 2. This side comes out to -4. And then over here, I have 4 over -1, -4. Okay, so 2, we're good. Let's check 3, though. What's going to happen? So when I check 3, I just get x plus 6 over 3 minus 3 equals 2x, and then over 3 minus 3. Oh, hey, Dodie, that should be a 3. Okay. I get 3 plus, oh, shoot. I'm going to have a 0 in the denominator. Same thing here. We know that cannot happen. Cha-cha-cha. So we would say that 3 is an extraneous solution. Okay, you solved for it, but when you plug it back in, it doesn't actually satisfy the equation. So all sorts of fun stuff happening. So sometimes it will look like a 0 in the denominator, and sometimes it will look like you just plug it in, but the left side doesn't equal the right side. So that would be extraneous. So if I asked you what is the solution to this, the solution just would be 2. So just as a heads up. So that's our lesson for today, guys. It has been a pleasure teaching you that. So you're going to do a few problems today, and then we'll kind of build on this as we're going forward. So please let me know if you have any questions. Have a great day.